Hello pre-calc students, I'm recording the inverse section of the pre-calc packet. So for problem 63, f of x is equal to negative 2x plus 1, which means that to find the inverse, we have to switch the x's and the y's. So x is equal to negative 2y plus 1, subtract 1 from each side. X minus 1 equals negative 2y. Divide each side by negative 2. So the negative 2's cancel out, and y is equal to x minus 1 over negative 2. There we go. That's problem 63. For problem 64, f of x is equal to 3 times the square root of x minus 4. So x is equal to 3 times the square root of y minus 4. Okay? And then from this point, you can divide each side by 3. So x over 3 is equal to the square root of y minus 4. Square both sides. So x over 3 squared is going to be equal to square root of y minus 4 squared is just y minus 4, and then to isolate y is going to be equal to x over 3 squared, add 4 to each side, plus 4. Now, one thing I actually need to do is write things in inverse notation. So if that's an inverse notation, I want to finally write f to the negative 1 of x using inverse notation. So the inverse of f of x is x minus 1 over negative 2. Or you could also write negative x plus 1 over positive 2. This would be the real solution set here. So, and here I'm going to write, if that's the inverse function, then the inverse of f of x is equal to x over 3 squared plus 4. So that's 64. Solving for 65, f of x is equal to 3 times f of x is equal to 3 times x minus 4 cubed plus 1. So x is equal to 3 times y minus 4 cubed plus 1, which means that x minus 1 over 3 is equal to y minus 4 cubed. Take the cube root of each side. So the cube root of x minus 1 over 3 is equal to y minus 4. I'm going to add 4 to each side. So that means the 4's cancel out, and y is equal to the cube root of x minus 1 over 3 plus 4. So you find the inverse of f of x, the inverse of the function is going to be equal to the cube root of x minus 1 over 3 plus 4. All right, that's 65. For 66, x is equal to y squared minus 8x plus 12. And we're going to have to complete the square here to get this into vertex form. So in order to complete the square here, we're going to have to add our complete the square terms. All right, so to complete the square, we have negative 8, which is our b term, divided by 2, which is negative 4. Negative 4 squared, which is going to be equal to 16. All right, so negative 8x is equal to 16. We have 16. So we're going to have 16 plus x is going to be equal to y. This term, this perfect square term here will be y minus 4 squared. Notice the reason why I knew this was being a factor is because that minus 4 corresponds to this minus 4. Y minus 4 squared plus 12. So I'm going to get I'm going to subtract 12. Yeah, so now I can get y by itself. So I'm going to get subtract 12 from each side. And then I can get x plus 4 equals y minus 4 squared. Take the square root of both sides. That's going to give me the square root of x plus 4 equals y minus 4, which means that y is equal to the square root of x plus 4 plus 4. And so the inverse of f of x is going to be equal to the square root of x plus 4 plus 4. All right, that is our answer. Okay, sorry, I did. Problems are screen's glitching a little bit here, but I can keep moving down as this thing buffers. Problem 67. F of x is equal to negative 2 times 3 to the 2x power minus 1, which means f of x is going to be equal to negative 2 times 3 to the 2x minus 1. So to find the inverse, we're going to have to switch the x's and the y's. Get our pen. We will have. Sorry, the computer's being a little slow here. X is equal to negative 2 times 3 to the 2y minus 1. All right, and now we need to isolate y, so we can have x plus 1 is equal to negative 2 times 3 to the 2y. Divide each side by negative 2. We will have x plus 1 over negative 2. Negative 2's cancel out, is going to be equal to 3 to the 2y. All right. Use logarithms, take the change of base. So x plus 1 over negative 2, log base 3, the log base 3 of x plus 1 over negative 2 is going to be equal to 2y. So that means that to figure our final answer, reduce our thickness here, the inverse of f of x, f to the negative 1 of x, is going to be the log base 3 of x plus 1 over negative 2 divided by 2. That's the inverse. So that's 67. For 68, let's reduce our thickness, x is equal to the ln of 3 minus y. So let's move to black. So now we can, now remember, x is equal to the log base e of 3 minus y. So we can do our swoosh. E to the x is going to be equal to 3 minus y. Alright, and that's the swooshing the logarithm. E, start with E, to the x, swoosh to x, equals 3 minus y. Swoosh back to 3 minus y. So e to the x equals 3 minus y. Subtract 3 from each side. So e to the x minus 3 is equal to negative y, which means that positive y would be equal to negative e to the x plus 3. So the inverse of the function, f to the negative 1 of x, is going to be equal to negative e to the x plus 3. And that is our function right here. Great. That's the inverse section of the packet.